Imagine there's a secret language, a hidden code that kind of holds the blueprint for every single human being. It's this universal dictionary that lets doctors from all over the world speak the exact same language when they're talking about the huge, vast spectrum of human variation. So let's crack this code open and see what it's all about. 4,000. Now, that's not just some random number. That's roughly how many different medical conditions a person can be born with. That's an immense landscape of human variation, all happening before someone even takes their first breath. So, with thousands of possibilities, how on earth does a doctor in Tokyo communicate clearly with a researcher in Toronto, right? How do they make sure they are talking about the exact same condition when it comes to tracking it, treating it, and studying it? That's the big question. Well, the answer lies in this universal classification system. I want you to picture a gigantic global library of human health, where every single known condition has its own unique call number, just like a book. This system, it's officially called the ICD-10-CM, and it's the absolute key to bringing order to all this complexity. And we're going to focus on one specific section of that library, Chapter 17. This is the part that's all about conditions that are present at birth. Every single one of them gets a code, somewhere between Q00 and Q99. And listen, this isn't just a simple list. It's a structured, logical language that is the foundation for everything from your personal medical records to global health research. Okay, so we've got this powerful book of codes, but how do doctors and researchers actually use it? In the real world, what are the basic rules of this medical language? Let's break it down. It all starts with something called the alphabetic index. The best way to think about it is like the master index at the back of a massive textbook. A medical coder looks up a condition here first, and the most important question it helps them answer is this. Was this condition present at birth, what they call congenital, or did it develop later in life, which is acquired? Getting that one distinction right is the first crucial step. And this is where you start to see just how incredibly specific this whole system is. It can even tell the difference between when a condition showed up relative to birth. So if a deformity happens in the womb, it's congenital and gets a Q code. But if it's an injury that happened during the birth itself, it's considered perinatal and gets a totally different P code. I mean, that level of detail is just astounding. All right, now here's one of the most surprising rules of the whole system. A congenital condition is considered congenital for your entire life. It does not matter if it's diagnosed when you're 2 days old or 82 years old. If it started at birth, it gets a Chapter 17 code. Let's see how this actually plays out. Okay, picture this. A 30-year-old man goes to the hospital. He needs surgery for an aortic aneurysm. Now, on the surface, this totally seems like a condition of adulthood, right? Something unrelated to his birth decades ago? But then the doctors dig a little deeper, and they find out the aneurysm was actually caused by Marfan syndrome, a genetic disorder he has since the day he was born. That's the crucial connection. So even though the problem showed up in his 30s, its origin is congenital. And because of that rule, the diagnosis gets the code Q8740. In this system, where you started from trumps where you are now, every single time. So we get the rules now. Let's take a look at how these codes go from being just abstract numbers on a page into a really detailed picture of a person's health. Let's talk about spina bifida. This is a condition where the spinal column doesn't close all the way during development. Now, this isn't some simple one-size-fits-all diagnosis. So how does a coding system capture that kind of complexity? Well, the system doesn't just have one code for spina bifida. No way. It demands precision. The code actually changes based on the exact location of the defect. So whether it's up in the cervical region, which is your neck, or down in the lumbar region, your lower back. This level of detail is absolutely critical for treatment and for research. And the scope is just breathtaking. From chromosomal conditions like Down syndrome, to structural heart defects, to genetic disorders, to how your limbs are formed. Every single one has its own precise, globally understood code. It is nothing less than a complete catalog of the human condition at birth. Okay, so we have this incredibly detailed and, really logical system, but what's the payoff? Why does this hidden code matter so much in the real world? It turns out this code has 3 huge powers. First, it makes sure patient care is seamless. A single code can tell any doctor your exact medical history. Second, it's what drives the entire healthcare system, from insurance billing to planning what resources hospitals need. And third, and this one is a big one, it fuels global research. letting scientists track, study, and ultimately find cures. It connects one single patient to worldwide progress. So in the end, this whole system is so much more than just a list of codes. It's really an invisible architecture that shapes our health from the moment we are born. It's a powerful reminder that sometimes the most important systems are the ones we never even see. It makes you think, doesn't it? What other invisible systems are out there quietly shaping your life right now?